So Unit 4, Derivative Concepts continued. We're on Lesson 4 of this particular unit. And today's objective will be, how does the AP ask these questions about the limit definition of a derivative? Okay, we're going to see how they ask the questions. So, all right. So AP style questions for the limit definition of a derivative. So before I give them to you, let's kind of, you don't really need to write this, but you should pay attention because it'll make things make sense later. But let's say I gave you guys this. And I asked you guys to set this up for the limit definition of a derivative, okay? So the first thing that you would write, now we've learned two methods, right, for the limit definition. We've learned this one, bless you.
But wouldn't it be this way because you're not telling us to find an actual number?
That's a good point. I'm going to actually do it that way in a minute, but I want you to see both. Or it could be like this, right? But that's a good point, Mateo. Thanks for bringing that up. Okay, so we learned both of these. This is the regular one on the left here. This is what we call the alternative form over here on the right. So to address Mateo's concern, I'm going to say, for this side, I'll say find f prime of 2. But we'll get to that in a second. So for now, let's go ahead and set this up. So what's going to go here? What would I write? X plus h squared, right? Minus x squared over h. And let's do this one over here. We're going to find f prime at 2. So this is going to be limit as x approaches 2. F of, oh wait, Mr. B. Stem it down. All right, so what am I going to put here? Minus? No. 2 squared, right? You plug it in? And then x minus 2. Okay. Now once again, you guys don't need to write this, but I'm just going to, I'm going to change that to a 4, okay? Now, I didn't do this with these ones, but I'm going to do it now because this will help with those AP style questions. You can actually plug in a number over here for x as well. Okay, so for instance, on this particular problem, if I wanted to use this side to plug in 2, all you do is go through and get rid of the x's and put 2's there instead. It works. I was saying, remember how I told you guys what makes this one over here on the right special is the fact that you actually plug a number and you're finding the derivative at a specific point, whereas this one over here just finds you the actual derivative function equation thingy. Well, that's not necessarily true, and that's why I'm still in this dilemma. Like, why did they bother coming in for 2? Because you could do the same thing over here by just plugging in the number for x. It works. So you could set it up like this and get an answer. Now, here's the thing. Here's what the AP test is going to do. They're going to give you something that looks like this. Well, I'm not sure they'll give you one of these questions. They're not extremely popular, but I've seen one pretty much every time I look at a test prep material. But they're going to give you something like this. Now, I mean, you could evaluate these the old school way if you wanted to, but for some functions, you're not going to be able to. Like for this one here, you could just factor this, right? Difference of squares. Remove the discontinuity and plug in and get your answer, right? This one over here, you'd have to FOIL it out first, right? And then you could probably remove your discontinuity after that. But they're going to give you problems where you can't do it like that. And what they want you to do is they want you to see that this is not just another limit you're looking at. They want you to see that when you look at this, they want you to see that, oh, that's not just a limit. That's the limit of a difference quotient. That's a derivative. That's what they want you to do. They want you to recognize that's my y2 minus y1 over x2 minus x1. And they're applying a limit to it. So what they're really asking me to find is some kind of a derivative. Okay? And so in order to do this, you have to be able to identify two things, and then we're going to use the shortcut to get the answer instead of doing it the long way. And the reason for that is because, like I said, on the problems they give you, you're not going to be able to do it the long way. They're going to make it convoluted and complicated enough to where if you try to do it the long way, you would never get it done. Okay. So for instance, how can you tell? Do you guys remember what the original function was? It was x squared. How can you tell by looking at this what the original function was? I mean, I think you probably see it, but I need a better explanation than that. How can you look at this and know what the function was? Like if you were teaching somebody, like, and they said to you, what function was this person working with? What would you point at and say, okay, that's what the function must have been then? This one here? You're right. That's the piece you're going to look at. Now, what if the student that you're tutoring were to say to you, okay, so I know that my function must have been x squared because it's here I've got something squared, right? You guys good with that? But what number are we finding the derivative at? How do you know it's 2? Okay, so, but you're both right. Now here's the thing. This is the one you want to look at though, okay? This one, I wouldn't look here. You're right, that is 2 squared, and that might make you feel more confident, like, okay, that makes sense. If this is 2 and this is x squared, 4 being there makes sense. Okay, it must have been 2 that we plugged in. But sometimes this equation is so convoluted that just looking at this number alone isn't going to be very helpful to us. So what you want to do is look here, okay? So those are the two things you need to be identified by looking at this. You need to think, okay, what was my function, x squared, and what number did I plug in, 2. So what they're really asking us to find is f prime of 2, right? How can you tell over here? And if we're using the alternative form, how can you tell what the function was? That guy. This one's actually easier, right? It's that first thing right there. That's how you can tell what your function was. How can you tell what number you're working at? You could either look there or there, right? So, okay, so you guys might not be seeing the big pictures, but I actually gave you a homework question like this a few days ago. Ready? It was this. The limit definition of x approaching 0 for oh, no.
Mr. Bailey, this is no good.
Okay, so first of all, if I ask you guys to apply the limit definition to this, you might be able to do it. You could use L'Hopital, but I'm gonna ignore that for now. You might run into a problem. So let's go ahead and do a problem. Sorry. So what's our function? Now, first of all, do you guys see that as you're looking, this is not just another limit here. We have something minus something over our delta x here, which we're calling h in this case. So that's a difference quotient. And when you're taking the limit of a difference quotient, what are we really finding there? You're finding a derivative, okay? So we're finding the derivative of something, right? So first of all, what was my function?
Cosine finance.
My function is cosine, just cosine. But what number am I finding the derivative at? There we go. Right? So I could tell from here that my function was cosine. I can tell from here I'm finding the derivative at pi over 2. Now, instead of doing it the hard way and working this out, maybe using L'Hopital or something, we're just going to use our shortcut to find this. So what's the derivative of cosine? Negative sign. And then we're just going to plug that in. So sine of pi over 2 is 1 with a negative in front. There's my answer. So that's what that would equal. So it's a three-step process. You're going to look at this and you're going to say, okay, what's my function? What point am I finding the derivative at? And then use your shortcuts. That's how we're going to do it. Okay? And you'll see by the types of problems I give you today that you probably would have trouble applying the regular limit methods that we've learned to evaluate them because they make them so convoluted and confusing that they want you to be able to identify. They basically want you to be able to identify, oh, that's a derivative that I'm looking at. That's not just any old limit. That's a derivative limit. All right, so let's go ahead and do a couple of these. So we'll call this example 1 here. Go ahead and write down example 1. So here's our case in point here. Like, I don't know if you guys maybe were trying to find the limit of this old school style. You would have to raise this binomial here to the 4th power. That's a lot of work. That's like doing the box method 4 times. It's a lot of work and it would get really big. It would be overwhelming and confusing. There may be other ways to do it, but for now, I'm looking at this and I see y2 minus y1 over delta x. I'm like, okay, that's a limit of a difference quotient. This is actually a derivative. Oh, okay. This is not just a limit. This is a derivative problem. So, what is my function? It's x to the power of 4. Good. And they're asking me to find the derivative, because this is the limit definition of a derivative here. They're asking me to find the derivative at what x value? Negative half. So now I'm just going to use my shortcuts to get the answer to this, okay? Instead of working it out long way, we're just going to do our shortcut. So f prime of x. What is f prime of x? 4x cubed. And then I'm just going to plug in my what? Negative half. And then we're pretty much home free after that. So negative half to the 3rd power is negative 1/8, and 4 times negative 1/8 is negative half. So there's your answer to that limit problem, which is actually a derivative. Okay, so that's how they're going to ask it on the test. They want you to be able to identify that if that's a derivative, and they're going to expect you to use the shortcut rather than to evaluate this the old school way. Okay, that's it. So we're just going to do a couple of those today, and that'll be our lesson. We'll probably finish early. I don't know. We'll see. Because I originally meant this to be on a Wednesday, but you guys didn't come yesterday, so. I just think your lives are more important than math. What's the matter with you? Dorks. All right. Okay, go ahead and write down this one real quick. Okay, so I'm looking at this and I see this is not just any old limit. I see a difference quotient. So that's really a derivative. So I'm going to ask Julia. Julia, what's the function here that we're finding the derivative of? Uh-huh. Okay. Let's see if maybe Angelina can tell us. What do you think the function is? I think that's right. Because we look at this piece here. This is our x, and that's our delta x. We throw out the delta x, and there it is. All right. So now, oh no. Let's see, Jonathan, at what number are they asking us to find the derivative at? No. No, that's not correct, my good sir. Good guess, though. Vivian, at what number are we finding the derivative? 4. It is 4, because you remember, you want to look at this number here that's with the h. That's how you can tell. And then, like Mateo was saying, you can kind of get a little more confidence. Why is this 2? That's a square root of 4, right? Okay. So, now you guys can find the derivative. I showed you guys how to find the derivative of square root in 2 ways, okay? I'm going to review both of them with you really quick. So here's the older way. They're both shortcuts, but there's a faster shortcut. So first way I taught you was to do this, right? Multiply it to the front. Take 1 away from that. The negative puts it on the bottom, and the half is a square root, so there's that. Okay? But the faster way I told you was just to basically always jump straight to this. That's what it is. Just put it down there like that. All right? So whatever way you guys want to, go ahead and see if you can find, because the square root of x, we just found it earlier, was this, right? And then we're plugging in 4, which is 1 over 2 times 2, which is 1/4. And so this limit would be equal to 1/4. All right. Throw another one at y'all there. See how you do with that one. Okay, so let's see what you guys got. Thea, what's our function that we're finding the derivative at here? Tangent x.
Tax. It looks like tax.
Chloe, what number are we finding the derivative at? Okay. Neha, what's the derivative of tangent? Good. And so f prime of 2 pi over 3 would be secant squared of 2 pi over 3, and that's where a lot of you guys stopped. So, do we know what the answer would be? What is it? 1/2? I think you're rightish, but not done. I don't know. I don't think so. Yeah. Anybody else? Okay, so check it out. So secant is the reciprocal of cosine, right? So I'm going to find secant of 2 pi over 3. On the unit circle, where's 2 pi over 3? Second quadrant?
First top.
There we go, it's right there. Now secant is the reciprocal of cosine, so what's the x value there?
1/2.
Close. Negative 1/2, right? Okay. Now secant is the reciprocal of that, so what's secant of 2 pi over 3? Negative 2. But we are squaring it. What's the answer? Okay. So there you go. Okay. You go. All right. Savannah, what's the function?
ln x.
You're not Savannah.
Oh,
Savannah. Very good. Thank you, Savannah.
I think you're using.
No, he's not here. Let's try Nicholas Miller. We're finding the derivative at what value? 4. Oh no. Amanda, what is the derivative of ln of x? Huh? That's the final answer. But the derivative of ln of x is 1 over x, right? And so when you find the derivative at 4, it would be 1 over 4, and therefore that's what this limit would be. Okay? Now the next ones, I'm going to switch it up on you a little bit.
Oh,
You kidding me? Wow.
You guys don't even know what you're wowing at.
wow.
What's the difference, Mr. and Mrs. Wow out there? What's the big difference?
That's the alternative one.
Woo! Look at you! I'm proud of you. She used the vocabulary and everything. So proud of you. I didn't think anybody would notice. Shut up.
Okay.
Sure. All right. So when you're doing the alternative form, you got to look at it a little bit differently. Because remember, with the alternative form, you have, instead of just an h on the bottom, you have x minus a number. Then you have your function. You have what the function would be at that value that you're using. So it's a little bit different than the one with the h on it. So let's go ahead and take a look at it. So what would the function be here? It would be x squared minus x. Okay? And what value am I finding the derivative at? 2. So, what's f prime of x? 2x minus 1.
I only thought you meant
Wait, what?
Which is 3. There's your limits.
oh my gosh. Wait,
Did I go too fast?
no.
Yes, it
All right.
Hi, class.
So,
This is Unit 4, Lesson 4.
okay. Let's review derivatives really quick of absolute value functions, okay? So,
You have to set them less than.
Wait, we already wrote them.
well, you could, if you want to change them into piecewise, you could, but I think that I gave you guys a shortcut for finding derivatives of absolute values, okay? Here's how it works. I just think.
You don't even know your own choice.
You just put that absolute value over the number itself, but without the absolute value bars. Okay? And since this is a chain rule, you didn't even multiply it by the derivative of the inside. It's okay. So that's how you do it. Okay? So you take the absolute value, you put it over what was inside the absolute value, but without the absolute value bars, and if there's an inside, you multiply it by itself. We did that like one day a while ago.
That's to find the derivative, right?
Of an absolute value function. Yeah. So before I set you loose on that one, I want to let you guys practice it a little bit. So you don't have to write this. You can just pay attention though. So what if I gave you guys this? The absolute value of cosine x. So what am I going to write? I heard Coco.
Cosine. The absolute value of cosine is
Okay, good. The absolute value of cosine x over cosine x
times negative sine x.
Good. You guys got it?
Yes.
Okay, so that's our shortcut. There's a longer way to do derivatives of absolute value functions, but that's our shortcut, and that's what I want you guys to use today. So, see if you can do this one. Caitlin, what is my function here? I agree. And what is the derivative of that function, James?
I'm gonna have it.
It's the absolute value of x plus 5 over x plus 5 times 1.
Good. And I'm just going to leave the times 1 off, but you can have that. It's fine. Pearl, I'm finding the derivative at what value?
3. I was just gonna-
Trisha, what's the final answer? Well, how about you tell me what this equals, and we'll call it even. Well, this is 8, right? Like you said. But it's 8, absolute value of 8 over 8. The absolute value of 8 is 8. And 8 over 8 is what?
Drug time.